Hi, hello, welcome back to the Math Club, Matthew, where you'll get content based on math for class 9th and 10th. In the last video, we discussed about representing real numbers on number line. If you have not watched that video, please do check it on our YouTube channel. In this video, we'll be discussing about decimal expansion of real numbers. Today, let us learn about decimal expansion of real numbers. So we know real numbers are of two types. One is rational number, the other one is irrational number. So a real number can be either rational or irrational. So in the previous video, we discussed that rational numbers can be kept in two ways. One is P by Q form. Another one is decimal form. Okay, not only rational numbers but even irrational numbers can be kept in decimal form. So let us see how we can write certain rational numbers and irrational numbers in decimal form. Let us look at the decimal expansion of these numbers. For example, I will take a rational number 2 by For example, I will take a rational number. For example, I take 4 upon 5. 4 divided by 5. We all of you know that 4 by 5 is a rational number because it is written in the form of P by Q, where P and Q are integers and Q is not equals to 0. Now let us try to write the decimal expansion of this number. 4 divided by 5. If I divide 4 by 5, I'll get 5 zeros are 0, 4. I'll take a decimal point over here and one more 0. 5 8s are 40 and 0, 0. So 4 by 5 can also be written as 0.8. So I can write 4 by 5 as 0.8. This is one kind of decimal expansion. Okay, so let me take one more number. For example, 1 by 3. I take the number 1 by 3. Let us try to divide 1 by 3 and try to write its decimal expansion. If I divide 1 divided by 3, 3 zeros are 0, 1 remainder, 0.0, 3 threes are 9, 1 remainder, 1 more 0, again 3 threes are 9, 1 remainder, 1 more 0, and again 3 threes are 9, 1 remainder. This 3 keeps coming on. So I can write 1 by 3 as 0.3333, etc. It keeps on going. Again we will be getting 3 infinitely many times. We are not even able to, and you can try it yourself once again if you want. Okay, so 0.3333 will be continuing infinitely many times. This is one more kind of decimal expansion. Look at this, both are rational numbers, but in this rational number we can see the numbers after the decimal is getting terminated in the sense it is stopping at some point. Here we can see that the numbers, the digits after the decimal point is never terminating. They are just repeating infinitely many times. So such kind of decimal expansion we call it as terminating decimal expansion. Why? We can see that 0.8 is 0.8 itself, 4 by 5 is 0.8 itself. Nothing comes after that. 0.8 is finished. So nothing comes after. It has stopped. The decimal expansion has an end over here. So we call it as terminating decimal expansion. If you look at the decimal expansion of 1 by 3, we have 0.333333. Here we can see that decimal expansion is not at all ending. In this case, we call it as non-terminating decimal expansion. Here there comes one more kind of non-terminating. If you look at this, in this non-terminating decimal expansion, the number 3 is being repeated again and again. Yes or no? So instead of writing 3 infinitely many times, we simply write as 0.3 bar. This bar on the top of 3 means this 3 is being repeated again and again in the decimal places. This bar over here represents 0.3333. Suppose you are having 0.56 bar, it is 0.565656. If you are having 0.56 only bar on top of 6, it is 0.5666. So this is what bar does. Bar is used in place of repeated decimal places. Okay. So if you look at it, 0.3333, 3 is being repeated again and again. So we call this as non-terminating repeating decimal expansion. Non-terminating repeating decimal expansion. Non-terminating repeating, or it is also called as non-terminating recurring. Non-terminating repeating or non-terminating recurring decimal expansion. Both are correct. There are two usages. One is non-terminating repeating and non-terminating recurring decimal expansion. Okay, so these are two kinds of rational number, two different rational numbers having two different kinds of decimal expansion. One is terminating decimal expansion, terminating repeating decimal expansion. Any rational number will either have any one of these decimal expansion, either terminating decimal expansion or non-terminating decimal expansion. Every rational number will have either one of these decimal expansion for sure. Then what about irrational numbers? You might have heard of irrational numbers. Give me an example of irrational number. I'll take root 2. Root 2 is an irrational number. What can be the decimal expansion of this number? We know root 2 is a rational number. Then how to find out a decimal expansion of root 2? In class 8, you might have studied about long division method of finding the square root of a number. If you apply that long division method of finding the square root, you will get square root of 2 is 1.4142135623 dash 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 dash. Now what difference can you observe in this decimal expansion from these two? If you look at this, this is terminating, entirely different. This is non-terminating. Even this decimal expansion is non-terminating. Some number is being repeated, still it goes on up to infinity, infinite number of terms. Then what can be the decimal expansion of, what kind of decimal expansion is this? Can you look at difference in these two? Yes, the difference is, in this decimal expansion we can see that the number 3 is being repeated again and again, whereas in this decimal expansion we have 1.41421356 dash 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 dash. Number is being repeated in a particular pattern. The numbers are being repeated but not in a particular pattern. No pattern is being followed in the repetition of numbers here. So this also belongs to non-terminating decimal expansion group. Non-terminating decimal expansion group. But what kind of non-terminating decimal expansion? Non-terminating, and the numbers are also not repeating, so we call it as non-terminating, non-repeating decimal expansion. Non-terminating, non-repeating, or non-recurring. Both the usages are correct. Non-terminating, non-repeating decimal expansion or non-terminating, non-recurring decimal expansion. Every irrational number will have such kind of decimal expansion. Every irrational number will have such kind of decimal expansion. Always remember, rational numbers will always have only two kinds of decimal expansion, that is either terminating decimal expansion or non-terminating repeating decimal expansion, whereas all irrational numbers will have non-terminating, non-recurring decimal expansion. Now quickly try to write the decimal expansion of these numbers which you are looking on the screen and tell which kind of decimal expansion do they have.